Okay, good morning everyone, good afternoon, good evening, wherever you are. My name is Oscar Upio. Today I'll be taking you through that is a machine learning project that I'm working on. That is diabetes risk prediction using machine learning. So let us look at our key agenda for today. Shall basically have introduction, background introduction, problem statement. Shall look at the machine learning pipeline architecture, then the data set, until through our key findings, insights, then the next steps. So the background and introduction, that is, you see that diabetes represents a massive global burden where you find that we need to identify these risks early enough, and you find that in resource constrained settings, reliance on complex lab tests delays diagnosis. This is something very true, especially in Africa and possibly in other parts of the world. And then there's symptom-based screening, where you find in this case clinical symptoms combined with demographics offer strong predictive signals. So these features are accessible, non-invasive, and cost-effective for initial trigger diagnosis. Now problem statement. So basically we look at here in this case, in this label scarcity and diagnostic ambiguity. So we say that many patients present clinical symptoms but still lack definitive laboratory confirmed diabetes diagnosis. So in this case, what it does is request a scenario where we have abundant patient data but scarcity of ground truth labels necessary for traditional supervised learning. Then also the need for resource constraint trick or diagnosis. So the hospitals in these settings often lack immediate access to expensive test kits or diagnostic kits. So you find that there's a critical need for reliable computational trick models that can prioritize high-risk patients based on solely accessible demographic and symptom data. So our research questions, we basically want to know the clinical features that are mostly associated with diabetes status, and can we quantify their predictive power. Then we want to use the unsupervised and semi-supervised learning paradigms. Then we go ahead to also have an end-to-end machine learning pipeline, and now this drives us into our module architecture. So in this case, we look at that is our machine learning architecture. It is a two-phased architecture which is divided into 10 steps. So that is from data sourcing, data ingestion, data preprocessing, exploratory data analysis, feature engineering, module selection, module training and hyperparameter tuning, module evaluation, module deployment, and module monitoring. So as per this presentation, or as per the progress so far, I'll walk you through from step 1 up to step 8, that is module evaluation. Module deployment and module monitoring, that will come in a subsequent presentation after the module has been deployed to a production environment. So let's look at beginning with data sourcing. So in this case, for my case, my data source, I used a .csv file. You could possibly have a different data source that can be an IoT data, that is a live streaming data, that can possibly come from an REST API, that could be a data source. So for my case, this is a .csv file which has about 520 records and 17 features. Now after identifying your data source, what do? You go ahead to ingest your data. So what does ingestion mean? So data ingestion simply involves loading data from its source into your working environment with the proper validation and versioning. In this case, we need to handle potential issues like large file sizes, encoding problems, and detect quality checks at point of ingestion. So in this case, basically I've just extracted this from my IDE, that's my VS Code, to show you my data ingestion results. In this case, I've considered the first 5 rows of the data. So as you see it, where in this case basically the features age, gender, polyuria, and then polydesgia, then sudden weight loss, weaknesses, and the list goes on up to the 17th. Now we are in the third step of the machine learning architecture I'm using, which is a very well used or well known architecture. That is, now we are looking at data preprocessing. So basically what this involves, data preprocessing is critical for ensuring data quality and consistency. We'll handle missing values, outliers, data type conversions, standard categorical values. This stage ensures our data is clean and ready for analysis and modeling. So the key preprocessing steps include, that is, handling missing values, detecting and treating outliers, fixing data types and format inconsistencies, removing duplicates, standardizing categorical values, and documenting all transformations that we do. Now in this case, let's look at data exploration or exploratory data analysis. Why this is important? It helps us understand patterns, relationships, and anomalies in data. So I basically took a screenshot of my summary statistics of my data shape, the columns. Here I looked at basically the numerical column, age. So you can have this analysis on your data by doing data exploration. Still on the data exploration, we can possibly have distribution. In this case we have age distribution, and in this case we're looking at, if you look at the distribution, it almost follows a bell-shaped curve, which is a normal distribution. So let's look at, that is still gender distribution. So in this case, if you look at the pie graph or the pie chart, you see that is female takes about 36.3%, and then the balance of 63.7. I mean, female takes 36.3, then male takes 63.7. Then if you look at the graph of variation of gender with diabetes, so this is still giving us the distribution of the attributes with our target variable, that is diabetes status. So we go ahead to look at our other features and how they and their prevalence as it comes to us in regards to diabetes. So that gives us a better understanding. Sometimes the distribution, you see that it's right skewed or left skewed, or it follows normal distribution. That informs your decision making as far as the data set handling is concerned. Now the next thing we're looking at, that is feature engineering. So what feature engineering basically, it involves creating new features from existing ones to improve module performance. We will encode categorical variables, create interaction features, and prepare the data for modeling. So basically the key steps in this phase or in this step involve that we encode categorical variables, scale numerical features, create interaction features, feature selection, and then prepare a final data set for modeling. In this case, let's say your data set has a date feature. You could engineer it and have, let us say, day, week, month, year, quarter, something like that. So in this case, let's look at feature importance. So feature importance, basically you do a ranking of the top most important features in your data set. So in my case it was, that is polyuria, which supposed to be the most important feature in my data set, with a ranking score or a mutual score, information score of 0.25643, followed by severe symptom with a mutual information score of 0.40727, which if you round off to precision of 3 decimal place, that is 0.205, and the list goes on for these other features. Now Now let's look at model selection. So this one of the most important steps, or one of the most important thing you will do in any machine learning project. So basically, this model selection involves choosing appropriate algorithm for our classification problem. We will select multiple algorithms and justify each choice based on problem characteristics. So in this case, what's our problem? The one you're dealing with, it is a classification problem, and which classification problem? It is a binary classification. A yes or no, positive or negative. In this case, diabet, positive or negative. And after you have identified your classification problem, you need to go ahead and identify the success metrics. So in this case, my success metrics involve accuracy, precision, recall, F1 score, AUC-ROC. So in this case, what are the selected algorithms that I have considered? 1. Logistic algorithm, baseline model, interpretable. Then random forest, and nonlinear relationship feature importance, XGBoost, SVM, then KNN, which is simple instance-based learning. Now, I did model selection. I basically chose 3. So in this case, that is random forest. This is a result from my computation. Random forest had an accuracy of 0.9123 plus or minus 0 with an error of 0.0101. Then training time was about 7.645 seconds. XGBoost had an accuracy of 0.8963 plus or minus 0.0237 with a training time of 1.804 seconds. Then KNN, that is K nearest neighbors, had an accuracy of 0.8803 with an error of plus or minus 0.0287. Training time of 0.170 seconds. Then, so I actually considered about, that is 5, but I prioritized, that is I prioritized 3. So the other 2 I considered, that was Logistic Regression and SVM, to make 5 with it, random forest, XGBoost and KNN. Now afterwards I went ahead to do the model training. So in this case, this involved splitting data, handling class imbalance, training candidate models, and hyperparameter tuning. Well, basically I used 3 models from the selection stage. In this case, this was my selection. That was the 5 I had. Then I had to choose 3. So the key steps I took basically was train, validate, and test, split, handle class imbalance using SMART, hyperparameter tuning using GridSearchCV, then train final models, then self-trained models. So in here, that is model training. So I'm looking at now the comparison of the 3. I had to choose again 2. So you can say from 5 to 3, from 3 to 2, and ultimately I chose the overall best after training all of them. So with XGBoost, it showed that is cross evaluation score, that is F1 score of 0.924. Then random forest at 0.865. So then the training time 209.0 with XGBoost. Then random forest 293.3 seconds. Now I went ahead now to do model evaluation. Now these are the methodologies, or the components, or the things I consider to make an informed decision. Okay, I can go with this model, I can leave this model. So 1, the multiple key metrics. This involved accuracy, precision, recall, F1 score, AUC-ROC, confusion matrices, ROC curves, learning curves, feature importance analysis, and then final model selection. These are the key evaluation components, or the evaluation criteria. So now accuracy and precision. So I wanted to realize that okay, XGBoost had the highest accuracy of 0.905. Then random forest had the best second accuracy, that was 0.889. Then precision score, XGBoost had a precision score of 0.904. Then random forest had a precision score of 0.888. Then model evaluation, still I'm considering recall and F1 score. So if I look at recall, that is XGBoost had a score of 0.905. then the random forest had a score of 0.889. So you can see that just from this comparison, you can see that XGBoost is leading. Now random forest, it has 0.889. Then F1 score, XGBoost 0.903. Then random forest 0.886. Then confusion matrix, still I also considered it when you look at the random forest and then XGBoost. So at the end of it all, I came to a key finding and a conclusion after successfully evaluating the module. So I got to a conclusion that XGBoost was the overall best module with the test set performance of 0.843, precision of 0.7986, then recall of 0.7843, F1 score of 0.7887, then AUC-ROC of 0.9045. So now my next steps, basically it will be to deploy this module and then do module monitoring. So to deployment, that means putting the module to the production environment that is on the server and integrating with a given application or where it will be used. Then module monitoring, this involves building a performance dashboard that will help me to see how the module is performing, and also ensure that if there's a drift, it is handled, and as we add in more data or let me say the behavior of the patient's change, the model should be able to work still reliably, predictably, and consistently. Now I used some reference materials, that is some books, and obviously some online, a lot of online resources. So that was it all for this presentation. My upcoming presentation will be on the deployment. It will be on the deployment. Otherwise,